Hi everyone. Today I'm going to talk about how to properly evaluate a new database for your solution with more confidence. So my name is Natasha, and I'm a senior software engineer and architect with over 12 years of experience. And for the past 4.5 years, I've been working in Oribi web analytics and facing data challenges on a daily basis. I love software and system design, and especially working with data, and I find database products fascinating and inspiring. And at this point, I'll tell you my first disclaimer, which is that I'm not a DBA. However, in my years of experience, I know that choosing a database can be crucial when designing your system, which makes this task super important for every software engineer out there. And while the task of choosing seems straightforward, as software engineers, we more than often fall short performing this task, simply because we either fail to properly understand our data or we fail to properly evaluate the chosen database. So the scenario I'm talking about is when you have a new feature or system that you need to implement, and this feature introduces a certain complexity you do not have experience with. And this feature obviously involves manipulating, storing, and querying data. So if you're lucky, you get a solid PRD from your product team, and if not, you should go to lengths to fill the gap, but essentially you should have a list of requirements, including what queries should be supported, the expected concurrency of them, how data is ingested, and what data volumes we're talking about. And you should know the expected SLAs and the requirements for data freshness. And this list will probably include a bunch of other things. And now, armed with this list, you continue to choosing a database. And you want to do a really good job, and you want to pick just the right one. So many times the choice of database will be straightforward. You will have your experience, your intuition, and usually the company you work in will have a group of already in use database and all at your disposal. So onto this collection, and let's assume that this is it. You start projecting your requirements. And while you do have experience working with them, because your feature holds this complexity that you haven't implemented before, you are unsure if either of these databases will fit the requirements. And so you start wondering naturally if there is a better DB out there. And you start reading and investigating. And pretty quickly, depending on your experience, of course, you are in danger of getting overwhelmed because there are a lot of databases out there and more are coming out by the year. And each database excels in different scenarios, and each database's homepage will state that it's absolutely the best thing for every single use case you have. So in short, you are even more hesitant than before. Because how are you supposed to come to the right decision without having experience working with these new databases? So take a breath and start at the beginning. And since obviously not all databases are even worth considering, it's a good idea to make sure you truly understand your data and you focus only on appropriate candidates. So, as you all know, there are several database paradigms, and there are a lot of excellent posts and sources out there on how to choose the right DB for your use case. And they vary between presenting and comparing different database paradigms, listing the pros, the cons, and exploring appropriate use cases for each. And you also have the deep dives into paradigms by examining the properties of specific databases, such as persistency, scale, and performance. But this is not that kind of talk, and I'm not going to talk about which database you should choose and how, but rather I'm going to focus on the next step, which is how you evaluate a database for your feature. So let's say you talk to some friends in the industry and you consulted with a bunch of companies about your use case, and now you have a leading candidate database that you think will be a good fit. So if this is a new database and not one of your go-tos, you're still scared because starting to use a new database is not always an easy decision for a company. It involves a leap which translates to money eventually, right? So it's hard coming to your boss and telling them, hey, let's choose this solution I have absolutely no experience with, but I think might be a good fit. It's not easy, and you wanna gain more confidence before doing that. But you're not sure what you should check, how do you start, and with what. And more importantly, how do you measure these elusive things that accompany any new technology, like ongoing maintenance and R&D time, and the solution's resilience in your setting, the flexibility? So if only you had the ability to glimpse into the future and to know how this database will actually function and behave with this feature already in production. That would be amazing, right? Because you would see how it behaves with a scale, with the proper data. You would understand the maintenance issues. You would already have experienced them, and then you would be done. But until quantum physics is more advanced, I guess, you should start with a POC. And I know this sounds pretty straightforward because we always POC a new technology before choosing it, and I'm not telling you anything that is new. However, when dealing with data and with databases, properly evaluating it involves more than just setting it up and testing queries. And for the rest of this talk, I'll go over a checklist that I gathered that you should definitely evaluate and score your database against in order to truly gain more confidence before deciding whether this is a good fit or not for you. And I will also share why this is not as straightforward as a regular POC. Not in terms of time, investment, and even money, but why it's still very much worth it, and I hope that I will be able to convince you. So let's start. And what you'll start with is implementing a lightweight version of this feature, and you should include the queries and preferably the data ingestion. And by doing that, what you'll essentially gain is the ability to estimate the product fit and the technical limitations. So you will have to structure your data and construct your tables and indices and start writing the queries and make sure that all access patterns are supported by the query language, by the features of this database, and you want to make sure that the queries run in a decent time. You will also have to understand how to insert data into the database and whether this database is even suitable for your write and update needs. And what I mean by technical limitations is that you will find that maybe some specific features are not existing to support a specific type of query. Or maybe the way data is ingested into this database affects data freshness, for example. So these are the types of things you will learn to understand already at this stage. And now a good idea would also be to include matrix at this stage of implementation with some earlier thought about how you're going to benchmark your performance for later. And also another thing you want to consider is how flexible your solution is. So for example, consider any data alterations. What happens if you'll want to add more columns? What happens if you are required to support additional queries that are slightly different than the ones you know of? And see how flexible this solution really is. So now that you have a working implementation, you will want to start moving to testing performance and scale. So remember, you want to emulate production as best as possible in order to get the confidence you need. And if things were relatively easy until now, this is when it's getting complicated and it stops being just like the regular POC. So in order to test performance, you would ideally simulate production data volumes and production query concurrency. So for that, you will need to stream data into your database, and this could be a timely task. And at this point, if you feel data ingestion is a risk, it's definitely worth investing in implementing and testing data ingestion now. And if not, just choose the easiest and fastest solution, and you can deal with properly implementing it later. And you can use load testing tools to simulate query concurrency. And then you would want to time your queries to understand the performance of your implementation. Is it stable over time? Is it stable over different segments of your data? For example, say you have data that is associated for different customers. Try to see if you can optimize queries by maybe constructing the data differently, or maybe the queries a bit differently. And check if maybe some database configuration fine-tuning is needed to help boost your performance. For example, slightly different allocation of resources. And after you've done that, you want to move to testing scale. So the first thing you should understand is what scaling options are even available. Is your database the kind that scales vertically, just by increasing resources like storage or compute. Maybe it's a solution that scales horizontally. And you want your database to be set up using the production deployment already and not locally, of course. And here the choices are usually between fully managed service, a semi-managed by your cloud provider, or fully managed by you. And for the deployment of choice, you want to understand whether auto-scaling is an option, is scaling done manually, how data is affected during scaling up and down. Is there a rebalancing operation that is required? Should this be performed manually? Is data availability affected during a rebalancing operation? And again, you will also want to simulate 10x data volumes or maybe 100x data volumes in query concurrency to experiment these scaling operations, and also to experiment how your implementation will behave for a higher scale. So until now, our evaluation concentrated on the actual usage of the database and its options and performance. And there are 3 more super important points you should include in your evaluation. And luckily enough, they are based on the work that you've already done. So hopefully it's mostly a matter of some calculations at this point and retrospective. So let's start with the first one, which is a very interesting point, and that is the cost. So depending on the database and the deployment, you should understand what you're going to be billed for and what this bill is comprised of. And there can be several options here, because if you're using a database that is a fully hosted and managed service, you will be billed for a license. If this is a product that is hosted on your environment, an additional hardware cost should be considered. And by looking at this implementation that you already have, which is, like we said, very close to production, you should already be able to know what the required hardware is and what the pricing model that suits you is. And then you can just compute the expected price. And of course, this is an estimation, but it's a pretty good one by now. And of course, you can also try to emulate the 10x increase in volume and concurrency, so you can also estimate the expected price for future scale. Now, as promised, most of the work is done, so let's take a look at the last 2 points that are crucial to understand and that hopefully, after experimenting in almost production environment, you can score. So these 2 points are the maintenance and the learning curve. So take a look back and estimate them. Do you feel that this database was easy to learn how to use? Does it have a strong community you can consult with? Is it mature enough in terms of stability? How much maintenance did you experience? What kind of operations were required from you? So once you're done scoring all of these 7 points, take a step back. And do you feel differently about your database? Do you feel more confident recommending it for your feature? So regardless of whether your research will result in choosing or not choosing this database, which is also a viable option, you should definitely feel more confident with your choice. Because all of a sudden, this new database is not so new anymore, and you already have some experience with it. So I know this sounds like a lot of work, and let's put it out there, it is. It's also going to cost money for the company to do this, the setup, the hardware, the R&D hours, and you need to make this clear to your managers. And you won't always be able to do it all, let alone do it thoroughly and perfectly. But my best advice for you after doing this whole process recently at work, is set yourself with concrete milestones for this POC and estimate what you can't check thoroughly. And I promise that as long as you will do at least some of the work, any work out of these things, your confidence will grow. And the more you do out of this process, the more your confidence will grow with it. And on a final note, please remember that there is no such thing as a bad database, only a mistreated one. So try to evaluate your database of choice as well as possible so you won't end up mistreating yours. Thank you very much.